this video, there are two steps. The first step is optimizing the manufacturing price of a 2-liter can of paint, and the second step is to optimize the shipping price. So let's say there is a 2-liter can of blue paint. And there are two variables, r, which stands for the radius in centimeters, and also h, which stands for the height in centimeters. So before we start, we have to say something. So 2 liters equals 2,000 cubic centimeters, which is also centimeters to the third. And the side, which has the variable h in the equation, costs 3 cents per square centimeter. And the top and bottom costs 3 5/10 cents per square centimeter, which is also centimeters to the second. So an equation for finding the area, which is the same as the surface area of a cylinder, is 2 pi r to the second plus 2 pi r h. This is because pi r to the second is the area of a circle, and there are two of them, so that is the top and bottom. And then 2 pi r is the circumference, and then that's just multiplied by h, so that's the side. So this equation is not a function. And this is because there are two variables, r and h. But to make it a function, we can find the value of h using algebra from the volume, which has to be 2,000 cubic centimeters. Now we can divide all the sides by pi r to the second, so then we just have h. This gives us h equals 2,000 over pi r to the second. So now, putting this into that equation, we have 2 pi r to the second plus 2 pi r, and now 2,000 over pi r to the second. And we can simplify this, so the pi's cancels out with each other, and we can divide the numerator and denominator by r, so we get 2 pi r to the second plus 2 times 2,000, which is 4,000, over r. So now this equals a of r, the area function. So now coming back to the side, equals 3 cents per square centimeter, and the top and bottom is 3 5/10 cents per square centimeter. Now the first part of the area function is the top and bottom, and since that is the top and bottom area, we can just multiply that by 3 5/10. And the other part of the area equation is the side area, so then that can just be multiplied by 3. If we do so, we get 3 5/10 times 2 pi r to the second plus 3 times 4,000 over r, which then equals 3 times 5/10 is 7 times pi r to the second plus 12,000 over r, which equals this cost function of r. We don't have to graph it, but just to show it, I'm going to do it anyways. So the graph looks something like this, and the place that we're trying to find is the lowest point of the y-axis on the graph, which is called the local minimum. And this occurs when the rate of change of the function equals 0, which means the original function is not increasing or decreasing, so it's not changing at that moment. Looking at the graph of this function, it looks like the local minimum happens about at r equals 8, but we want to be more exact, so we'll find the derivative of the function. So c prime of r equals, then the first part is 2 times 7 pi r. And the next part could also be written as 12,000 times r to the negative first. So now the derivative of that would be negative 1 times 12,000 times r to the negative second. And this equals 2 times 7 is 14, so times pi r, and then minus 12,000 over r to the second. Now I'm just rewriting it over here. And graphing it looks something like this. And the local minimum looks like it occurs about where r equals 8. So now finding the value of r where the derivative of the function equals 0, we have r approximately equals 6 and 485 thousandths. Say if we didn't graph it and we want to be completely sure it's the local minimum, because it could also be a local maximum, then we would want to find the derivative of c of r and put in r equals 6 and 485 thousandths, and if that's positive, then right after that the rate of change is increasing, so then the original function is increasing. So now c prime prime of r equals 14 pi, because r to the 0 is 1, minus, then this is the same as negative 12,000 times r to the negative second. Then we have minus negative 2 times 12,000 times r to the negative third, which equals, so the negative symbols cross out, so it's positive. So now we have 14 pi plus 24,000 over r to the third. Now let's write it over here. So we have 14 pi plus 24,000 over r to the third. And now having r equals 6 and 485 thousandths for the derivative of the cost function, we have it approximately equals 131, which is positive, so it has to be a local minimum. So now coming back to the height function, which equals 2,000 over pi r to the second, and also that the radius has to approximately equal 6 and 485 thousandths. And putting that into the height function, we have 15 and 1/10, so that's what the height should be. And now the area equation, which is 2 pi r to the second plus 2 pi r h, putting the radius and height into that equation, it approximately equals 879 and 5/10, so that's how much total materials they need per can. And now to make sure the volume equals 2 liters, going back to the volume equation, pi r to the second h approximately equals, putting r and h into the equation, 1,995 cubic centimeters, which approximately equals 2 liters. And it's not exact because we rounded for the value of r. And now from the cost equation, c equals 7 pi r to the second plus 6 pi r h. Putting r and h into that equation, it approximately equals 2,770 cents, which equals $27.70. Now we have finished step 1. Now for step 2. So let's say there's a 1 kilometer wide river and it has a factory on one side and also a town on the other side, and the distance between the two is 10 kilometers. And there are 2 ways of transportation, a boat and a truck. The boat travels at a speed of 1 kilometer per hour, and it costs $5 5/10 per kilometer. And the truck travels at a speed of 5 kilometers per hour, and it costs $5 every kilometer. And we're assuming that the acceleration is so small it doesn't make a difference. So the river is 1 kilometer wide, and the distance between the factory and town is 10 kilometers. It might look like the truck should go all the distance it can and the boat should just go across, but actually, if the boat has to go across the river at all, it might as well do it in an efficient way. The distance that the boat travels is the hypotenuse of a right angle triangle that is 1 kilometer wide. So to find the function of the distance of the hypotenuse, we have to find the side that's not 1 kilometer or the hypotenuse. So to find that, if we make the distance that the truck travels d, then that side would have to be 10 minus d. So then the distance of the hypotenuse would be the square root of 1 to the second plus 10 minus d to the second. And that was using the Pythagorean theorem. So first we want to find the total time function, which is t of d, and then we can use it to find the total cost function, which is c of d. So in this case, the rate is the velocity. So then the velocity times the time equals the total distance, which is also the rate times t equals total distance. So then we come back to r equals d over t, which is the velocity. So that checks our answer. Using algebra, r is the velocity. So now coming back to the rate times time equals d if we divide both sides by r. So then we get an equation, t equals d over r, which also equals d over the velocity. So now from the distance function of the boat, 1 plus 10 minus d to the second plus, and then the distance of the truck, d, then that equals the total distance function, so td of d. Now we want to find the total time function. So it's just the square root of 1 plus 10 minus d to the second, because that's the distance, and now over the rate, which is the velocity, so over 1, which is just the same thing, and now plus the distance that the truck travels over 5. So now we want to find the total cost function. So now the rate equals the cost over the distance. So then, using algebra, the rate times the distance, if we multiply both sides by d, equals c, the cost. The truck costs $5 per kilometer and also travels 5 kilometers every hour. Now to combine this, we see that it costs $5 every kilometer and it travels 5 kilometers per hour. So if we divide both sides by 5, then it travels 1 kilometer every 12 minutes, because a fifth of an hour is 12 minutes. S equals 60 seconds, which is a minute. So now combining both of those, we have over here $5 every 12 seconds. But the total time function is in hours. So then if we multiply the seconds times 5, then we will have to multiply both sides by 5. So then it's $25 every hour. And then this, it travels 1 kilometer per hour, so it's just 5 and 5/10 dollars every hour. So now we just multiply the cost by the time function because the cost is in time. So we get 5 and 5/10 times the square root of 1 plus 10 minus d to the second, plus, and then d over 5 times 25. If you divide both sides by 5, it simplifies to 5d, which then comes back to the rate times the distance equals the cost. This time we're first going to find the derivative of the cost function. So we see that the first part, it's the same as 5 and 5/10 times 1 plus 10 minus d to the second, and then that to the 1/2. So now using the chain rule, we have 5 and 5/10 times 1 over 2 times 1 plus 10 minus d to the second, then to the negative half, times the inner part 2 times 10 minus d times -1, because d to the 0 is 1 and it's negative. So now this equals over here. The 2 cancels out with the 1/2. So it's negative 5 and 5/10, then times 10 minus d. And since the next part is to a negative power, it's over the square root of 1 plus 10 minus d to the second. The derivative of the cost of the truck is just 5 because d to the 0 is 1, so plus 5. Now I'm rewriting it over here. Now we're going to graph it. So this is the graph of the cost function, and this is what the slope looks like at the local minimum. And this is the graph of the derivative of the cost function. And from just looking at the graph, we see that the local minimum happens about at d equals 8. Putting in where the derivative equals 0, we have d approximately equals 7 and 817 thousandths. So now say we did not graph it, we want to make sure it's a local minimum, so we will find the derivative of the cost function. So seeing that the first part could also equal 1 plus 10 minus d to the second to 1 over 2, we have to use the product and chain rule to find this. So we have negative 1 plus 10 minus d to the second, and then that to the negative 1 over 2. And from the product rule, we have times the derivative of 5 and 5/10 times 10 minus d plus 5 and 5/10 times 10 minus d, then times the derivative of 1 plus 10 minus d to the second to the negative 1 over 2. So now it equals negative, then we have 1 plus 10 minus d to the second, because that doesn't change, to the negative 1 over 2, times, and this time we'll start with the inner part, so negative 1, because d to the 0 is 1 and it's negative, and now the outer part is just 5 and 5/10, plus 5 and 5/10 times 10 minus d, because that part doesn't change, and then times from the inner part, -1. So now from the outer part, the derivative of a constant is 0, so the 1 gets cancelled out. So it's just times 2, then times 10 minus d. And now from the outer part of that, we have -1/2 times 1 plus 10 minus d to the second, and then to the -3/2. And we can simplify this so it equals, then the negative symbol crosses out with the negative symbol on the 1/2, and the 2 can cancel out with the 1/2 because it just equals 1. And now we still have the negative symbol on the other part of it, so we have negative and then 5 5/10 times, since we have 2 10 minus d's, so 10 minus d to the second, and then over 1 plus 10 minus d to the second, and then to the 3/2. And now minus 5 5/10 over 1 plus 10 minus d to the second, then to the 1/2. And then we can simplify this even more. So since there's a negative symbol, it equals -1, so we can multiply both sides by -1 by each side. So now we have 5 5/10, because that becomes positive, over 1 plus 10 minus d to the second, then to the 1/2, minus, that becomes negative, 5 5/10 times 10 minus d to the second, then over 1 plus 10 minus d to the second, then to the 3/2. And we can even simplify this even more. So the way to do this is if we take the common denominator and then just simplify that, which then if we do that, we get 5 5/10 over 1 plus 10 minus d to the second, then to the 3/2. Now I'm just rewriting it over here. And now that graph looks like this. So now putting the derivative of the cost function, and having d equals 7/817 thousandths, then the derivative of the cost function approximately equals 3,972 10,000ths, which is positive. So then that means it is a local minimum. So now we have the truck travels 7/817 thousandths kilometers, which equals 7,817 meters, because 1,000 meters are in a kilometer. And now the boat travels not the distance it actually travels by the hypotenuse, but 2 183 thousandths kilometers, which equals 2,183 meters. And now for the distance that the boat actually travels from the hypotenuse of the right angle triangle is the square root of 1 plus 2 183 thousandths to the second, which approximately equals 2 and 401 thousandths kilometers. So that's the distance it actually travels, which equals 2,401 meters. So now the price of the shipping to get it to the town from the factory costs $52.29. So now to finish this video, we have the total price of packaging and shipping for this paint factory equals 27 and 7/10, which is the price of packaging, times Q, which is the quantity, plus 52 and 29 hundredths, which is the cost of shipping.